Trains may be pretty ancient in many respects. With long-distance travel largely reserved for planes in modern culture, a long-distance train, as a method of public transportation, might be regarded as an orthodox rather than the go-to alternative. Japan, on the other hand, is committed to completely change that. Let us explain how. In this video, we will be talking about Japan's $100 billion train called the Maglev L0 passenger train, which is considered the fastest train in the whole world. Hello and welcome to TechLux. Here, you can find all things techie related and further improve your ideas in order to become financially stable. Also, please do subscribe with all notifications turned on and like the video. Now let's get started. Since its unveiling in the press in November 2012, Japan's world record-breaking Maglev L0 passenger train has been under testing, reaching speeds of 374 miles per hour. The technologically sophisticated train is eventually scheduled to travel in Chuo Shinkansen line, which connects Japan's capital Tokyo to the significant provincial city of Osaka. The first phase will run around 2/3 of the way to Nagoya by around 2027, with the final Osaka section going online around 2045, nearly 100 years after Japan's first considered maglev technology. The $47 billion construction of the Nagoya phase, 85% of which will run in tunnels, a distance around 185 miles, to take only 40 minutes. When the 250-mile road to Osaka opens, it will take just 1 hour and 7 minutes to reach the capital, a significant time reduction when airport check-ins and city center train station locations are considered. The entire cost of the Osaka is anticipated to reach around $100 billion. Maglevs, of course, combine a variety of technology to attain their astonishing speeds. Perhaps the most important is the notion referred to in the name of magnetic levitation. The train is the sole moving element of the system. However, the Japanese system is known as the SC Maglev. Maglev trains utilize a system of superconducting magnets to push and hold the train away from its track, which is normally a U-shaped guideway. This has a significant advantage in that the train does not really sit on anything but hovers a very tiny distance above the track, eliminating the major source of friction that would otherwise delay the train. A second magnet system is utilized to move the train, with the alignment of poles on the magnets used to simultaneously repel the train and pull it forward utilizing attracting forces on one hand and repelling forces on the other. When the system is cooled to a low temperature, it becomes extremely efficient, and while it can be costly to set up, the lack of moving parts means it's actually cheaper and more dependable to run. And the lack of friction creates that speed. Other advantages of maglev systems include a smooth ride caused by the train's complete absence of touch with the path it is traveling. It is also impossible for a maglev train on a track to reach another train since the track regulates the speed, which is the same of every train traveling on it. That implies there is no danger for accidents between trains. That said, there are several conditions for having world's fastest train, or indeed any maglev train, but not enough to prevent China and South Korea from running the same system that is now operational in Shanghai and between Seoul and South Korea's southern coastline. The unique track layout of the maglev, which cannot share with more ordinary trains, is one such necessity to run system, making it a pricey setup. Furthermore, due to the train's speed, it requires limited and reasonably gentle bends, which might be a limiting factor depending on the area. In reality, concerns surrounding the tunnel constructions have been a key delaying factor in Japan, coupled with environmental complaints, particularly about the tunnel's influence on water levels in nearby rivers. The financial effects of the coronavirus outbreak have also had an influence on the project's finances, which rely on some extent on passengers utilizing the traditional train system and may cause the project's opening to be delayed. The project is still moving forward, and plans to conduct a Tokyo Olympic trial rides before a worldwide audience were prevented by the coronavirus. The Maglev L0 train, which is being tested in Japan by the JRC Central Japanese Railway Company, has built the technology to the greatest level seen internationally thus far, which has helped push the speed out to 374 miles per hour in testing. The highest speed is unlikely to be reached on commercial trips, which are estimated to top out a closer to 300 miles per hour, but it may go even higher under experimental settings. Tourists may already experience the train by scheduling a special type of preview trip on the Yamanashi Maglev test line, the 26-mile circuit on which the train set the speed record while pulling no less than 7 carriages at a time. In testing, the train was also able to cover 2,500 miles in a single day. The most current variant of the Japanese maglev is named the improved Maglev L0, and was released in May of 2020. It improves on the original power system by allowing electricity to be supplied through the track, as well as developing the aerodynamics of the front car and adding an onboard generator so that if the power is uninterrupted, the train will simply glide to a stop. Aerodynamic enhancements are thought to be significant, not just for the train's speed, but also for the noise it creates as it cuts through its surroundings so swiftly, making the train seem more comfortable in a commercial environment. While this current model is unlikely to be the final one, designer Motowaki Terai informed the media that it satisfies 80 to 90% of the train's ultimate design objectives and, like the previous iteration, comprises a 12-car set. For the time being, the actual trial train is a mix of the two separate versions, including some modern and some older carriages. Once operational, the trains will reduce the current 2.5-hour train journey between Tokyo and Osaka by more than a half. The reporters were clearly pleased when they were given the opportunity to inspect the technology of the test track, which has hosted over 2 million test miles thus far. There may soon be maglevs in the United States as well, with a projected northeastern corridor route between Washington, D.C. and Baltimore eventually meant to include New York under consideration. The negotiations on whether building may resume are thought to be ongoing, having halted during the Trump administration owing to a lack of support. Virgin Hyperloop and Elon Musk's Boring Company both employ comparable technologies. Having said that, operational maglevs are still a rarity across the world, but they're an effective and somewhat ecologically friendly means of providing a middle-distance transportation at very high speeds, especially when airport check-in delays are taken into account. Japan's development as a functional mode of transportation is not yet complete, but when it is, it will be market-leading. Do you like the mode of transportation? Would you want to travel fast at low altitude? Would you contemplate going to Japan simply to give it a go? And is it worth the billions of dollars? Let us know in the comments down below. Thank you so much for watching this video. Please do like the video if you learned something valuable and subscribe with all notifications turned on so that you won't miss any of our future uploads.